A 70-gram bullet moving east at 400 meters per second strikes a 1.2 kilogram block on the right and becomes embedded in it. How high will the bullet block system rise above its original point? Okay, so let's assume, because it doesn't tell us, but I'm guessing that this problem came with a picture and we just don't have it. Let's assume I have this block that's attached to a rope that's attached to some connection point here, and then I have this bullet. Okay, and my bullet, it's probably a lot smaller than that, but just so we can make a picture, this is moving at some initial velocity. So this is my before, and my after. I'm gonna have my spot here, and then let's assume that, erase that and do a little better job. So let's say this is my block now, and my bullet's embedded in it, so like that. And we'll just draw this, and this is gonna be my height. How high will the bullet block system rise? So that's gonna be my Y height that we're looking for. Notice that this is gonna have a velocity, right, as soon as it hits. So let's do kind of an intermediate spot here. So I've got my block, right? And once it's embedded, then it starts to move. So that's going to have a velocity final here. So this is kind of like before and after for momentum. And then this is going to be like before and after. Let's say this is before and after, right, for the energy. So we'll say this is before and after for energy. And then this is before and after for momentum. Spelling momentum with a P. Okay, so let's start. So it looks like we're going to need to do two things. We're going to need to, let's do our givens and finds first. So given, we have our mass of the bullet, and so that's 70 grams. So let's write that in kilograms, and we'll say 0.07 kilograms. The velocity of the bullet is equal to 400 meters per second. And let's call that the velocity initial. And the mass of the block, call that BL, and is equal to 1.2 kilograms. And now get finds. The first thing we want to find is the speed right after the collision. So we'll call that V final. And so that'll be our A. And our B is, and so we're going to find this with momentum. And then we're going to find our Y height so this is going to be, let's call this Y final. We'll call this Y final. Our final height, we're going to find that with energy. All right, so let's start with A. So in A, we're going to use the momentum equation. So we're going to say P initial is equal to P final. And so we're going to have M of the bullet times V of the bullet initial plus M of the block, BL, times V of the block initial is equal to mass of the block, or the bullet plus mass of the block times V final. Okay, and we know that the block is not moving at the start, so we'll make that equal to 0. And we're trying to find V final, so we're trying to find this. So I'm going to divide both sides by mass of the bullet plus mass of the block. Divide this by mass of the bullet plus mass of the block. Cancel that out. And I get V final is equal to, I'm going to start plugging in. So let's see, my mass of the block is 0.07 kilograms divided by 0.07 kilograms plus 1.2 kilograms times 400 meters per second. So for my V final, I get 22 meters per second. Okay, so that's my part A. I get the momentum, right? And so now what I want to do is I want to use the energy part of this equation. So notice that my right here, my y right here at this spot, this is going to be my y is equal to 0 height. So right after the collision, my bullet block combination is at y equals 0, and then after it starts moving, right, it rises up here to be at y final. So that's what I'm going to be looking for. So let's do part B. So part B is conservation of energy. So I'm going to say that K initial plus U initial is equal to K final plus U final. And I'm going to say that there's no delta E thermal because I'm not talking about friction or anything like that. And notice here that before, right, the blue before, my height is 0. So I'm going to have 0 potential energy and all kinetic energy. And then after, when the block reaches this spot right here, it's going to be all potential energy and no kinetic energy. So the block will have stopped moving. All right, so that tells me then I'm going to have this is 0 and this is 0. So now I have kinetic energy as 1/2 mv squared is equal to mgy final. And this V right here is going to be this V, right? So I'm going to be plugging in the velocity that I found from a momentum equation. Um, and I'm looking for y final. I can cancel out my m's because they're on both sides of the equation. So my y final is going to equal v squared over 2g. And when I plug that in, so my y final is equal v squared is 22 meters per second divided by 2 times 9.8 meters per second squared. And I get y final is equal to 1.12 meters. So that's how high the bullet block combination goes after the bullet hits the block, and then they move together to their highest point.